All right, welcome to 10.3. We're going to look at multiplying radicals. So, the product rule for radicals states the following. As long as your roots or indices, remember they're also called an index, if they are the same, then you're allowed to multiply what's inside the radicand together. All right? Now, what's important here that I want to point out up here in the top is that when the directions are going to say multiply and simplify. They're wrong. It's always backwards. You want to simplify first, then multiply. And when we get to those problems, I'll show you in great detail how it works. So as I said, if the roots are the same, we multiply it what's inside together. So for example, I have the cube root of 2 times the cube root of 7. Multiply the 2 and the 7 together, you get the cube root of 14. Again, there was nothing here to simplify. We'll go through the simplifying part first, then we'll get to multiplying. These are just straight multiplication. 2 square roots, here we go. This is a trick question. We bring the two binomials, multiply them together. We're going to have to FOIL it. It's a difference. They're conjugate pairs to give us a difference of perfect squares. You cannot take the square root of x squared and the square root of 4 because this is technically still in parentheses. And the parentheses are not squared. This is my final answer. Do not tell me the answer is x minus 2. It will be wrong. Here we have the fifth root of 3x squared times the fifth root of 4x. Just multiply the insides together. We're going to get the fifth root of 12x cubed. If we have fractions, fourth root of 11 over x times fourth root of y over 5. Bring the two together on the inside. Fractions, you just multiply straight across. 11y over 5x inside the fourth root symbol. All right, now let's talk about simplifying. Simplifying radicals, we're going to use our product rule. But what we want to do is to find two factors that are exactly the same. Since this is a square root, we are looking for factors that are the same. And right off the top of my head, I see 9 and 8 for 72. They're not the same. We can break down the 9s to a 3 times 3, and the 8 is 2 times 4, and 4 breaks down the 2 times 2. Well, here's a pair of 3s. 9 is 3 squared, and if you take the square root of 3 squared, you get a 3. 4 is a perfect square. You take the square root of 4, you get a 2. So if it's an even root, 2, then we're taking everything out in groups of 2. Now, this 1, 2 that's left over, it's not in a group of 2. It stays on the inside. So we multiply 3 times 2. We get 6 times the square root of 2. What I don't like, what a lot of authors are going to tell you in books, is they're going to say, oh, 72? Oh, you're looking for the largest perfect square as a factor. It's 36 times 2. Well, we don't know that right away because, look, some of these numbers are going to get huge. So that's ridiculous to try to attempt that. All right, we have another square root. We're looking for things in groups of 2. We're going to use the Gazinta rule. Easiest thing to do is your variables first. 2 goes into 2 once. 2 goes into 5 twice with 1 left over. Variables are done. Now we're going to go attack the number. Now, because this number ends in a 75, I'm guessing 25 is a factor. I'm going to divide 25 into 675 and get 27. Well, 25 is a perfect square. There's a pair of 5s. And 27 is 3 times 9, so 9 breaks down to a pair of 3s. So the pair of 5s and the pair of 3s come out as 1. And the leftover individual 3 stays on the inside. And my answer is 15xy squared times the square root of 3y. Now remember, because this x is to the first power, you have to put absolute value bars around it. All right, our next one, it's another square root. Let's do the variables first. 2 goes into 13 6 times with 1 left over. And 2 goes into 20 10 times with nothing left over. So the variables are done. My variables have even powers. I will not have to worry about absolute value bars. 11,340, I'm going to go with 20 as a possible factor. So I go to my calculator, divide by 20, I get 567. So 20, I know I can break down to 4 and 5. 5 plus 6 plus 7 is 18. So that means this number is divisible by 9. If you take the sum of the digits, and if it's the sum of the digits is divisible by 3 or 9, the whole number is divisible by that value. So 567 divided by 9 is 63. Now, 63 has a factor of 9 in it, so I'm not going to break this 9 down. I'm going to grab those pair of 9s, grab those pair of 2s, move them out front with my a to the 6th, b to the 10th, and my leftovers go into the inside, and we multiply outsides and insides together, and there's my final answer. Okay, next, cube root. Now things have to come out in groups of 3. So as I break this down, it ends in 5. I know I can divide by 5. 27, I know is 3 times 3 times 3. So now I need to take things out in groups of 3. This is like saying the cube root of 3 cubed is 3. Don't forget to put the root or index of 3 on the ledge. Then put your 5 on the inside. We have 3 again. We're going to do the Gazinter rule to our variables. So 3 goes into 3 once, and 3 goes into 11 3 times with 2 left over. Now we're going to attack the number. Remember what we said earlier about cube roots. You can take the cube root of a negative, so immediately just take the negative out front. I'm going to break down 1,500. I'm going to go 2 zeros. I'm going to go 15 and 100. My 15 is 3 times 5. My 100 is 10 times 10. 2 times 5, 5 times 2. The 3 5s come out to be a negative 5. And the 3 times 2 times 2 do not have a group of 3, so I multiply that on the inside as 12 and leave that with the z squared. Now, I get it. This is a lot of work in keeping track of things. I'm not going to argue with you. All right, so we might want to think of a smarter way to do this. All right, so my next example, I'm going to work smarter, not harder. Gazinter rule for my powers. Here we go. 4 goes into 13 3 times. That's 12 with 1 left over. 4 goes into 11 twice. That's 8 with 3 left over. But again, because the r was to the 3rd power, odd, and it came from an even root, you're going to need your absolute value bars here. Now, like I said, let's clean this all up. 432 is an even number. So I'm going to guess there's going to be a lot of factors of 2. So what I'm going to divide 432 by is 2 to the 4th power. So I go to my calculator, I type in 432 divided by 2 to the 4th. There's a group of 4 2's. Now, 27 we know is a group of 3 3's. We need 4, so there's no reason to break 27 down. So 27 is going to stay inside of our 4th root symbol, and we'll take the 4th root of 2 to the 4th, which is 2. We'll include it outside here, inside of our absolute value bars, or again, remember what I mentioned, if they don't like the 2 and the t squared inside, they only want the r cubed, we'll make that adjustment. Okay? All right, now we can start doing this with all these previous problems. Ends and zeros. Now, if I look back at this problem, because I didn't see 3 zeros, I wasn't going to try 10 to the 3rd. Therefore, I would go to a 5 to the 3rd or a 2 to the 3rd and see which one divides in evenly. Next, we have the square root of 3x squared minus 6x plus 3. I'm going to have to factor out a GCF of a 3. And then we're going to factor this trinomial. Looks like we're going to get an x minus 1, x minus 1. There's your two factors that are the same. We can write it as squared. So x minus 1 is going to come out front to the first power. Wait a minute. Came out of an even root. You need absolute value bars around that. All right, the fifth root of a negative 800 g to the fourth h to the sixth. We'll take care of our h here. 5 cannot go into 4, so g to the fourth stays. 5 goes into 8 once, with 3 h's left over. We can take out the negative. We know that's going to happen. And now I'm going to use my calculator here. I have zeros, so I know it's going to be a 2 or a 5. I don't see it being 5 because it would end in a 5. So I'm going to go with 2 to the 5th power. 800 divided by 2 to the 5th is 25. 25 is only 2 5s. I need 3. So it's going to stay on the inside. And the 2 to the 5th, after you take the 5th root, will be a 2. So we'll have a negative 2 out front. Multiply to your h times the 5th root. Again, don't forget the symbol or the index on the ledge. And 25 stays on the inside. Here we have the 6th root. We're going to do the Gazinter rule. Take care of your powers here. 6 goes into 21 3 times with 3 left over, and 24 4 times. But again, r to the third, that's odd, coming out of an even, so we need absolute value bars out here. 256, I'm going with 2 to the 6th because it's even. 256 divided by 2 to the 6 is 4. So I can take a 2 out front, and the 4 is only a pair of 2's, not 6 2's. So it stays on the inside again. I don't mind if you put the 2 and the t to the 4th inside the absolute value bars. The author might, then they just want the r cubed inside there. Okay, multiplying radicals. Multiply the insides and the outsides, write as one radical, and simplify. So what I encourage you to do here is notice that they're both square roots. You can rewrite them with both on the inside, but now I would start to break them down. All right, we got a 5 and a 3 and a 2. The pair of 3's on my square root will go out front. The 5 times 2 goes in on the inside. Here we'll take the 2 and the 3. They're on the outside. Keep them on the outside. Cube root, put 25 and 20 in. All right, let's break down. I see a lot of 5's here. 5 and 5, 5 and 4. These 3 5's will go out, multiply to the 2 and the 3. The 4 I know is only 2 2's. No reason to break it down. So we're going to get 30 times the cube root of 4. Next, we have 2 4th roots. So we're going to put everything on the inside. 24 times 10, group that together. X to the third, x to the 5th, add the powers to get x to the 8th. Y squared times y cubed, y to the 5th. Now we'll use our Gazinter rule. 4 goes into 8 twice, into y once with 1 left over, but because of y to the 1 power coming out of an even root, we need absolute value bars here. So I'm looking for a bunch of 2's. So 24, I know that's 3 times 8. 10 is 2 times 5. 8 breaks down to 3 2's. And there they are. Now, you could also do this by your calculator. How we talked about cleaning it up. You can go 24 times 10 in your calculator, then hit divided by 2 to the 4th, and you should get 15 left over. That 2 to the 4th comes out to the front, and there's our final answer. Next, section 10.4, dividing radicals. Again, everything has to be the same. Now, one thing you're going to notice in the directions on some of these homework problems is now it's going to say all variables will represent positive values. That means you no longer need to worry about absolute value bars. Again, the directions are wrong. We want to simplify first, then divide. So again, based on our rule, the roots are the same. You can divide what's on the inside. So here, both square roots, you can rewrite it as the square root of 80 divided by 10. Simplify the inside to an 8. Break it down to 2 times the square root of 2. There's a pair of 2's out front, the leftovers on the inside. 5 stays on the outside. We'll put the cube root of 32 divided by 4, which is 8. We just saw the cube root of 8, or 8 is 3 2's, so 5 times 2 is 10. The square root of 72x cubed y, 3 is on the bottom, so when we put this inside a 1 square root, there's a 1 out in front. Don't put the 3 out, it's got to be 1/3. Now reduce, 2 goes into 72, 36 times. X will go into x cubed 1 time for x squared. So we'll get a 6x square root of y. 1/3 times 6 is 2, so 2x square root of y. Notice here, x to the first, no absolute value bars because now the variables represent positive values. 2/4 roots, write it as one fraction on the inside and reduce. We'll get a 6, a to the 7th, and b to the 4th. And then we use the Gazinta rule. 4 goes into 7 once, 4 goes into 4 once. We have 3 a's left over. The 6 is just 2 times 3. We're done. Next, we're going to talk about rationalizing the denominator. One thing that authors will ask you to do is to remove one of the square root symbols from the top or the bottom. Traditionally, it's rationalize the denominator. So to do this, you need to say, well, if it's a square root of 2, I need 2 2's to simplify out of here. So what we're going to do is we're going to come up with a new philosophy. It's just enough to get by. I don't want to do extra work. So here, I would take, it's the square root of 7, the square root of 2. I need 2 2's. I'm just going to multiply by 1 extra square root of 2, top and bottom. So this will cancel out the square root to be a 2. And 7 times 2 is 14, so it's the square root of 14 over 2. So if you go to your calculator and you take the square root of 7, then divide it by the square root of 2, get your answer. Take the square root of 14 and then divide by 2, you should get the same decimal answer. Everything should check out. So there's your calculator check. On this one here, here's what I'm talking about, just enough to get by. It's amazing how many people will multiply by the square root of 15 top and bottom. No, these are reducible. I can reduce by 5. This is the square root of 4 over the square root of 3. And the square root of 4 is 2. All right, all I need to do is multiply by the square root of 3 top and bottom. I get 2 square root of 3 over 3. Don't do 15 because then you're going to have bigger numbers that you have to factor down and simplify. Another example, cube root of 5 over the cube root of 16. I see this, oh, I forgot, calculator check. There it is. It's all good. I've seen people here take this problem as the cube root of 5 over the cube root of 16 and multiply by 2 16's on the top and the bottom. No. 16 you can break down to all 2's. We can simplify this first as 3 goes into 4 once with 1 left over. So now I don't need to multiply by 2 16's. I only need to multiply by 2 2's. It's a cube root. I have 1 2. I need 3 2's. So I'm going to multiply by 2 squared inside my cube root symbol, top and bottom. So now I'll have the cube root of 8, which is going to give me a 2 times 2 is 4. 2 squared on the top is 4 times the 5, the cube root of 20 over 4. And the cube root symbol is underneath your math button. Next, bigger denominators. Always break down into prime factorization. It's amazing. Oh, it's a cube root of 12. I have to multiply. I have 112. I need 2 more. No, you don't. Break it down. 12 is 4 times 3, and 4 is 2 squared. 3 to the first, x to the first, y squared. I need to have all these be a power of 3. So what am I going to multiply by? Well, list down every factor in here once. I have 2 2's, I need 1 more 2. I have 1 3, I need 2 more 3's. I have 1 x, I need 2 more x's. I have 2 y's, I need 1 more y. That means all 4 factors are coming out of this cube root symbol, and I'm going to get 2 times 3 times x times y on the bottom. On the top, we'll multiply this all out. 3 squared is 9 times 2 is 18, x squared y. On the bottom, like I said, 1 2, 1 3, 1 x, 1 y. Now anything on the outside of the cube root symbol on the top, we can cancel and reduce. So there is the simplified answer, 4 times the cube root of 18 x squared y all over 3y. We have a fourth root. All right, here we go. Break 24 down, 8 times 3. 8 is 2 to the third. Now things have to come out in groups of 4. So I am going to multiply this by 1 more 2, 3 more 3's, 1 more x, 2 more y's. So 3 to the third was 27 times 2 is 54 xy squared inside my fourth root symbol. Now, the 2, the 3, the x, and the y, they'll all be to the fourth power when I multiply them out, and there they are. So the fourth root of 2 to the fourth, 3 to the fourth, x to the fourth, y to the fourth, all come out simplified. Now this 3y in front can cancel with the 3 and the y on the bottom, so there's my final answer. Here, nothing to break down or simplify. 2 is already a prime number, it's to the first power. So we need things in groups of 5, so I need 4 more 2's, 2 more a's, and 3 more b's. Multiply that up to the top. So I'm going to have, let's see, 2 to the fourth, that will be 16 times 7 is 112. A squared b cubed times my c, and the 2, the a, and the b all comes out in the denominator by itself, and we're done. Alright, so I want to go to the calculator again here real quick, give you a quick little lesson. Hopefully it won't crash. If it does, well, we'll just cut this video short and we won't do the calculator work. Come on, warm up. What I want to do is show you, oh, see it's having problems loading up. There it comes. Under the math button is your cube root symbol, and for your fourth, fifth, and sixth roots, that button's there as well, but it has a little X on the legend. I wanted to show you how to type that in. Again, not sure if you're used to graphing calculators or not. Here we go. So under the math, there it goes. Look at that. Underneath my math button, here's for the fourth root, fifth root. So if I hit number 5, whoops, second quit, clear the screen, math number 5, you'll get a text box out there. And I can put in a fourth root of 64 and get an answer. There is a decimal answer. Now, some calculators, when you do this, you'll have to put the root number first. So let's say we're doing the 6th root. I got to type the 6 first, then the math button, then number 5, and it'll put the 6 up there right away. So it all depends on what year your operating system is on your calculator. That's how you're going to enter your information. Okay? And again, all the problems we did simplifying, you can grade and check to make sure those decimal representations come out to be the same in both cases.